Hello everyone, welcome back to Scifun Academy, where science is made fun. Let me ask you something. What do secret codes, maths puzzles, and chemistry all have in common? Well, they all use symbols to unlock their meaning. And today, we are diving into the secret code of chemistry, writing chemical formulae. But first things first, what is a chemical formula? Have you ever seen these terms? These are usually accepted shorthand terms in casual communication, right? Like a quick way of saying longer phrases. Chemical formula is the shorthand form of communication for scientists. It tells us which atoms are in a compound and how many of them are there. For example, instead of saying that water molecule has 2 hydrogen atoms and 1 oxygen atom, we write H2 and O. Think of it like an identity tag for a compound. Just like your name is a short form of your whole identity. But how do we decide these formulas? Why do we write H2O as water and not H3O? And why is salt written as NaCl and not ClNa? What are the rules? For that, we need to learn about something called valency. Now think of valency as the number of hands an atom has for bonding. Humans have 2 hands, octopus have 8 hands, atoms too have hands. Not real ones, of course, but in terms of how many other atoms they can hold on to. For example, hydrogen has 1 hand, oxygen has 2 hands, and carbon has 4 hands. Imagine an octopus, OC, with 8 hands, trying to hold hands with humans, HU. Now humans only have 2 arms each, and to lock all the hands of the octopus, we need 4 humans. This would give us 1 OC and 4 HU. Or in other words, OCHU4. That tiny number at the bottom, called the subscript, tells us how many humans are involved in that handshake. Same thing for atom. CO2 tells us there is 1 carbon atom, but it needs 2 oxygen atoms to lock all its hands in the handshake. Same thing with H2O, and we can see why it cannot be H3O. But here's the thing, atoms don't always stay neutral. Sometimes they lose or gain electrons and become ions. This makes them charged. These charges are very important because compounds are formed when positive and negative charges attract each other and balance out. Alright, now that we know about valency and charge, let's learn about the rules for writing these chemical formulas. Here is the first and most important golden rule. The charges or valencies must balance. If one atom has 2 hands, and the other has 1 hand, you need 2 of the second one to balance. Same for charge. The charges must balance out. No leftover positive or negative. The second rule is that the metal always comes first, then the non-metal. Take the case of salt, for example. It is written as NaCl. Sodium is a metal and chloride is a non-metal. So sodium chloride is written as NaCl and not ClNa. This rule applies to all ionic compounds. For example, potassium bromide is KBr and not BRK, or magnesium oxide is MgO and not OMg, and calcium chloride is CaCl2, not Cl2Ca. Okay, and rule 3. For polyatomic ions or group ions, use brackets if there are more than one. What does that mean? Let's break it down. Firstly, what are polyatomic ions? So we already know about ions like Na+, Cl-, Mg2+. These are called monoatomic ions because they are formed with just one type of atom. Polyatomic ions are formed when 2 different atoms bond and form an ion, like OH-, called hydroxide. Other polyatomic ions include nitrate, sulfate, phosphide, etc. Okay, coming back to the rule. For polyatomic ions, use brackets if there's more than one. Take magnesium hydroxide. This is 1 magnesium and 2 hydroxide ions and is written like this. Now if we didn't use the brackets, MgOH2 would mean 2 hydrogen atoms only. But with the bracket means 2 full OH ions. So the rule simply says, if your compound has more than 1 polyatomic ion, use brackets. Remember these 3 rules and you'll never go wrong. Let's practice writing the formulae of some simple compounds. Let's start with a simple one. Hydrogen chloride. Hydrogen has a valency of 1 and chlorine also has a valency of 1. So this works well. The final formula is HCl. Next, hydrogen sulfide. Hydrogen has a valency of 1, but sulfur has a valency of 2. So, we need 2 hydrogen atoms and just 1 sulfur atom to get a balanced compound of H2S. The valencies get swapped in the formula. Let's look at another one. Carbon tetrachloride. Carbon has a valency of 4, but chlorine has a valency of 1. So we need 4 chlorine atoms and just 1 carbon atom to get a balanced compound of CCl4. Time for ions. Here's magnesium chloride. Magnesium ion has a double plus charge and chloride ion has a single minus charge. Now 1 magnesium ion needs 2 chloride ions to balance and give us MgCl2. Now let's look at an interesting one. Aluminium oxide. Aluminium has a charge of 3 plus and oxide has a charge of 2 minus. When we cross over the charges, we see that we need 2 aluminium ions and 3 oxide ions to balance. Does that make sense? Let's check. Total positive charge equals 6 and total negative charge also equals 6. So yeah, it's balanced. And swapping the charges gives us the correct formula. Okay, now I have an interesting one for you. Calcium oxide. Calcium has a charge of 2 plus and oxide has a charge of 2 minus. What is the formula here? Crossing the numbers gives us Ca2O2. But in this case, we can simplify this to CaO. Because as you can see, we just need 1 ion each to balance. The same concept holds for polyatomic ions, like sodium nitrate. Sodium has 1 positive charge and nitrate has 1 negative charge. So the formula is simply NaNO3. Okay, today instead of our usual quiz, we will practice writing more chemical formulas. Let's use this table for reference. Okay, ready? First one, calcium hydroxide. From this table, we can see that calcium is Ca with a double positive charge and hydroxide is OH with a single minus charge. So what is the formula? It is 1 Ca and 2 OH, CaOH2. Next, sodium carbonate. Sodium is Na with a single plus charge and carbonate is CO3 with 2 minus charge. To balance, we need 2 sodium ions and 1 CO3 ion. The formula is Na2CO3. Next example, ammonium sulfate. Cross the numbers again to get NH42SO4. Next, sodium oxide. Cross the numbers and get Na2O. What about aluminium chloride? AlCl3. Similarly, sodium sulfide? Correct, Na2S. Oh, what about aluminium sulfate? This one is Al2 and SO4-3. Okay, what about the reverse situation? Can you name a compound by looking at the chemical formula? Let's give it a go. CaCl2. Ca is calcium and Cl is chloride. So the compound name is calcium chloride. What about K2SO4? K is potassium and SO4 is sulfate. So potassium sulfate. KNO3? Again, K is potassium and NO3 is nitrate, potassium nitrate. Okay, one final one. CaCO3. This one is calcium carbonate. Wow, that was a lot of practice, guys. Great job hanging in there. Now let's take a look at some of the key takeaways from this. First one, chemical formula is a shorthand way to show which atoms are in a compound and how many. 2. Valency is like the number of hands an atom has to bond with others. 3. Golden rules for writing the chemical formulas. Valencies or charges must always balance. Metal comes first, then non-metal, and use brackets for multiple polyatomic ions. And there's the last one. Practice makes progress. Remember, balance the numbers. Make sure that the positive and negative even out in a chemical formula. In our next video, we will learn about molecular mass to wrap up Chapter 3. And that's it for today, folks. Thanks for watching. If you learned something new today, or just feel smarter than you were 5 minutes ago, hit those like, share, and subscribe buttons. And stay tuned for more mind-blowing science. See you in the next one.